Hello friend, welcome to the channel. Today we will discuss one of the interesting problem in dynamic programming. This problem is quite common and you can see the similarity in other problem as well. Generally we follow the same pattern. We should understand the problem clearly. Then we do pen and paper work, or you can think about whiteboarding. After that we will jump to the coding session, and at the end we should analyze the time complexity and the space complexity. Understand the problem clearly. So it says like a train can go from one station to the another station. For time being, we assume that train is going to the single directions. We generally show both directions the train can go. Here in the example we take 4 stations, station 0, 1, 2 and 3. When we go from one station to another station, there is a cost associated with that particular train fare. And the cost is given in here in the map. If we map this matrix like from one station to the another station cost matrix, let's draw it here correctly. So you can see the drawing. Basically we have 0, 1, 2 and 3. These are the 4 stations. We can go from 0 to 1 and also 0 to 2. So these are nothing but the cost associated with it. Like if a person can catch a train at 0 station and he wants to go to the station 2, the cost is 80. If the person wants to go from station 0 to station 3, the cost is 90. Similarly, if a person wants to go from station 1 to 3, the cost is 50. Now you can think about the person wants to go from 0 to 3 with minimum cost. It may happen like the person can go from 0 to 1 via one train and from 1 to 3 via another train. But he wants to minimize the cost. That is the problem. So how to solve this problem basically? So you see the common pattern here. The common pattern is like once we try to solve from 0 to 3 to make the minimum cost, the subpath 0 to 2 is also minimal. Down the problem into multiple subproblem. For example, while solving from 0 to 3, we break it down. Let's solve 0 to 1 first. Once we solve 0 to 1, then we can solve 0 to 2 and then 0 to 3. And going forward, we can go to the nth station. Let's solve the minimum one. If we start from 0, there is no cost associated with the 0 because we are there in the first station itself. So we just take a lookup table here which says about that what should be the optimal cost to reach to that station from the 0th station. So we are 0, so basically for the 0th station it is still 0. But from 0 to 1, we know there is no other way. That is the only one way, 0 to 1 we can reach, and the cost is 15. Correct? So we already solved this subproblem. Let's jump to the how much cost it will take from 0 to 2. So we have two options. We can go via 1 and then 2, or we can directly go via 0 to 2. As this substructure says, we already solved 0 and 1. Let's utilize them. If we go via 0, then we have L0, that is optimal value of L0 is nothing but 0, plus what is the cost associated with 0 to 2? It is 80. So what is the overall value? L0 plus C02 is 80. And we have also optimized value of station 1, that is 15. We can reach from 0 to 1 is 15. And what is the value from 1 to 2? It is 40. So the overall value is 15 plus 40 is 55. So we have this both value. Then definitely we can choose the minimum one. What was the minimum one? We have 80 and 55. The minimum one is 55. So what will be the cost value here? The cost value for second is 55, right? So we solve from 0 to 2 this subproblem. Let's move to the next one. Now, how to reach optimally from 0 to 3? Definitely, we have similar options. We can go from 0 to 3 directly. So L0 plus 0 plus cost of 0 to 3. We can go 1 and then 1 to 3, or we can go 2 and then 2 to 3. But the interesting thing here, this 2 is optimal. Like we know what is the cost value of 2. So we can go via 0 to 0, 3, or 1 and the cost value of 1 to 3, and 2 and cost value of 2, 3. And if we take the minimum one, you can see here basically this 90 comes for 0 to 3, because we can directly go from 0 station to 3rd station with a cost of 90. We can go via 1. What is the L1 is 15, and from 1 to 3 station, how much cost it is? 50. So 15 plus 50 is 55, sorry 65. And we can go via 2. L2, what is the cost? Is 55. And what is the cost between 2 to 3? It is 70. So 50 plus 55 plus 70 is 125. So we have all the three costs, 90, 65 and 125. What will be the minimum cost? Is 65. So we can see that if we go via 1 to 3, that will be the optimal one. So what was the actual answer? From 0 to 3 to go where? We can go from 0 to 1 and then 1 to 3. So that is the optimal one. So what was the overall cost? It was 65. We can do the similar process for the nth number of stations in the going forward. See the implementation file. If you see, we have a function called getMinCost. It is taking as a cost matrix as an input. This is basically 2D matrix, whatever we discussed before, how the matrix is given. For example, we see that the value of one stations to the another stations. The first one is for the 0th station to the other station value. This is the station number 1, 2 and 3 respectively. So what is the logic behind? I just did a basic check that we should have a number of station should not be empty. It should be at least one station. And for the safety purpose, I am assuming that it is a 2D matrix. It is basically the number of columns and rows should be same. So that is a safety check. Then the idea is exactly same. I created a lookup table. So an array that is initialized with 0 value with the number of stations that contains the optimal result basically. And initially start with the 0, so it contains the 0 value. Then we iterate through every station starting from 1 to n-1, and we initialize with for the ith station the logic is exactly same. We have to iterate from 0 to i-1 station, and for every station, like we did in the pen and paper, for every station we have to calculate who should be the minimum value. So for example, when we try to calculate the 3rd station, we have to understand what is the 0th station optimal value, and then from 0 to 3rd one, and the 1, and then from 1 to 3rd one, and second to 3rd one. So we have to iterate through 0 to i-1 stations. So we did the same thing in here. So we iterate through 0 to i-1, basically the current station -1. We take the cost, what is the lookup value, that is the optimal of ith one, plus the cost from I to the current station. Once we calculate the value, we just check that whether it is a minimum or not. Once we iterate through 0 to i-1, basically 0 to current station -1, we update the lookup value basically. So once we are done with these calculations, I think we are good to go. So what is the end result? We can print the end result, the final result in here. So if we run the applications, we can see that we feed the input exactly the same matrix and we get the updated matrix. The lookup table is 0, 15, 55 and 65. So the result is 65. Let's talk about the time complexity and space complexity here. If you see the time complexity, definitely you have to iterate through every stations. You cannot skip it. So order of n is needed. At the same time, for each station, you have to calculate from 0 to that station minus 1. So it also implies order of n. When the n goes to the infinity, a very big number, this also takes infinity. So the overall time complexity goes to the order of n square. In terms of your space complexity, as you're using a lookup table, that takes only order of n because the lookup table is only for the stations. So the space complexity goes to the order of n. I'll share the project to my GitHub account. Please check the description below to check out the code. If you like the video, please subscribe my channel to get more exciting videos on problem solving, and please share it to your friends. Thank you so much. See you next time.